Alright, this is a marathon of getting these kind of questions done, so let's get going here. I'm going to go over all the information that's in the problem first. It says let f be a differentiable function defined on the domain x is greater than or equal to -5, so these values are only when x is bigger than or equal to -5. It's known that f isn't decreasing, so that means that f prime is going to be negative on its entire domain and has a horizontal asymptote of y equals -3. That sounds like some extra information that they're giving you for later. Values of f are given selected at the table. And I told you guys in the last video, if you watch it, that the kind of problems that you're going to see will most likely have a table, an equation, and definitely a piecewise. Okay, so let's go ahead and see what we got here. We need g double prime. So g of x is here. I'm going to write this down because I wrote this down in my class a while ago. If you have an integral from a to h of x, of let's say m of t dt, what that's equal to is going to be and you have a derivative of the integral. So that's the most important part. If you have a derivative of the integral, let's just choose a different color here. You have a derivative of an integral, then what you're going to get is m of h of x. In other words, just plug in the limit of integration, but then multiply it times its derivative as well. Okay, and that's going to be, this is your F2C2. So you did this in your oral exam, you had to explain it, and maybe if you didn't do such a good job of that, revisit it. It will definitely come up. There's no way they're not going to test you on this. So please, please, please make sure you understand this. Okay, so for this problem, g of x was equal to that, so g prime of x is going to be equal to, and it looks like I'm going to plug in 3x squared into the t, so it's going to be f of 3x squared times the derivative of 3x squared, which is 6x. So that's g prime. I need g double prime though, so g double prime of x is going to be equal to, and I need a product rule here. So I'll do a first, and I'll do a second. And let's go see what we get. We're going to get a second prime, then we'll do a first. I'm just setting myself up. A first prime and a first, and we'll add it. Okay, so the first is going to be f prime of 3x squared. Let's change that direction and put underneath. F prime of 3x squared times 6x, and then times another 6x plus the first, let's go and change that back, plus the first, which is f of 3x squared, times the second prime, which is just going to be 6. And I believe that is the answer. You could clean this up if you wanted, but again, please, please, please be cognizant of time. You could rewrite this as 36x squared, f prime of 3x squared, plus 6 times f of 3x squared. You could rewrite it that way if you want to. Let me just check to make sure my answer is correct. And it looks good. Okay, let's go on to the next one. For B, explain why there's a value of c on the interval 0 to close interval 0 to 12 such that f prime c equals -1. So again, this could be an IVT or an EVT question. Not really sure. So it could be an IVT or EVT question. If it was an IVT question, they would have something in the table or something on a graph or something on an equation that would say that for your x values and your f values, they would give you a value that was here, that was probably greater than -1, and another value here that was less than -1, and your value should lie somewhere in between those. And that would be a table of f prime. That's how IVT would have to be applied. But you don't have a table of f prime, you have a table of f. So that means that this is going to be, I'm sorry, I said an EVT, I meant an MVT. But it's also 2:30 in the morning, so it makes sense why I'm making mistakes here. So this is going to be an MVT question. It's not going to be an IVT question. And if that part didn't make sense, my explanation of how you can identify if it's an IVT problem, rewatch that part again. So for the MVT, first I want to just make sure that the slope of the secant line, because that's what the MVT states, the slope of the secant line equals the slope of the tangent line on that interval. So let's go and plug in f of 12 minus f of 0 over 12 minus 0. F of 12 is negative 2 minus f of 0, which is 10 over 12. It looks like we get negative 1. So negative 1 is what I wanted out. The answer that I would write is this. There is a value of c on the closed interval such that f prime of c equals negative 1 because f is, and we highlighted it earlier, because f is differentiable on the closed interval and also continuous on the closed interval. And we'll give credit where credit is due. This is by the MVT. I should also state, because f is differentiable on the closed interval and continuous on the closed intervals, and f of 12 minus f of 0 over 12 minus 0 is equal to negative 1. I added one more little part here. I just wanted to add by the MVT to give credit where credit was due, and it fits more grammatically in that part. I'm just going to add that little part here that I need to add to make this all true. Divided by 12 minus 0. Okay. That's your answer for this one, and this is an MV2 question. This is basically the same thing that we had just written down. So let's go to the next one. This person does have a mistake on there, so it does need to say that, actually I'm going to highlight this big. This should say that f prime of c equals negative 1. Other than that, it looks fine. Okay, this one says find the value of x where g has a relative min and justify. So to find a relative min, we need g prime, and we have g prime. G prime of x we said was in part A. G prime of x was equal to f of 3x squared times 6x. Okay, in order to find a relative min, we need to find out where g prime is going to be equal to 0, or, so that's where horizontal tangents occur, or it could be where g prime is undefined. That could be anywhere where there's vertical tangents, or sharp corners, or cusps. But because they said that the function is differentiable, then we do not have this case, but it's worth noting because I noticed that on your oral exams we neglected that undefined characteristics of a critical point. So now let's go down to g prime equals 0. So this function has to equal 0. Okay, that can only mean a few things. That means that 6x equals 0, which implies that x equals 0. That also means that f of 3x squared equals 0. Now this one's a little bit trickier. To solve f of 3x squared equals 0, you need to look where the f value is equal to 0, and that's where x equals 9. So because 3x squared must equal 9, then x is going to be equal to plus or minus root 3. Okay, so we have three critical values, 0, root 3, and negative root 3, and we have to plug them back into g to see what we end up getting out. So let's go ahead and get a line test going here. So here's a line test. We have negative root 3, we have 0, and we have root 3. And since g depends on f, and I'm looking at g prime rather, so I'm looking at this equation here. Since I want to see what g prime is doing, I'm going to plug in numbers that I know I can evaluate pretty easily. So let's take a look at what kind of numbers they give me here. Well, let's take a look at it this way. F of 3x squared is always going to be positive. The way I know that f of 3x squared is always going to be positive is because it said the function was decreasing, and these values are just getting smaller and smaller and smaller, which means the functions before that were bigger and bigger and bigger, and positive. So these values were always positive. So now when I take a number on the left of negative root 3, On the left of negative root 3, I would get, on the left of negative root 3, I would get a negative number here, which means I would get a negative, because a positive times a negative is a negative. If I take a number in between negative root 3 and 0, well, that means I'm going to get a positive number still, because f is always positive, times a negative number, which is going to be a negative again. So no change at negative root 3. If I take a number here in between 0 and root 3, I'm still going to have a positive value because f is always positive. But on this side, though, I end up getting a positive number plugged in. So now I'm going to get a positive times a positive. So I get a positive there. On the right side of root 3, I still get the same thing, which tells me that my only maximum, my only relative minimum rather, is going to be at x equals 0. So we can say a relative min at x equals 0. And I think I always justify anyway. Yeah, I'm going to justify. Relative min, g has relative min at x equals 0 because g prime changes sign from negative to positive. Okay, and there's my answer. And there's the work that they did. For D, to evaluate this integral, the first thing I notice is I see that there's a function inside a function. And anytime I see a function inside a function, I'm thinking a chain rule, especially when the derivative of that composite part is in the integral. I'm going to definitely do a u sub. I think I said chain rule, but I meant a u sub. I'm going to check sin x and dx are in the problem, but I do have this extra negative, so I need to plug that on the outside. When I rewrite this, I get something a lot simpler, which is the point of u substitution. I get negative integral, leave those limits of integration blank, f prime of u du. The du came from the negative sin x dx, which was here. Negative. Actually, that's confusing. Negative, okay. Okay, now to get the limits of integration, I need to change this 0. Since x is equal to 0, let's see what it is when it's u. I have cosine of 0, which is 1, so this value is 1. And then to change pi over 2, x is pi over 2 here. So when I plug in pi over 2, I get 0. Now I have this negative on the outside of the integral, which I'm not really a fan of. I try to minimize how many negatives I have for any integral. So what I'm going to do is I'm going to switch these limits of integration around because I don't really like that they're backwards. And when I switch the limits of integration around, I take a negative out, which means now I get the integral from 0 to 1 of f prime of u du, and I like that better. To answer this question, I can either find the area or find the net change of the antiderivative. There's no area to be found, so I can just do f of 1 because f is the antiderivative of f prime. Minus f of 0. F of 1 is 5 minus 10. And you can leave your answer like that if you want to, or you can simplify it to negative 5. And that's your answer for D. For E, given that f prime of 3 equals negative 2, show that h is differentiable at x equals 4. This is kind of an intensive labor-intensive problem. Let's see what we can do. To show that something is differentiable, you must show continuity first. So we need to show that the limit, as x approaches 4, of h of x is equal to h of 4. Okay, we need to show that first. So let's go ahead and unpack this blue side here. You need two things. You need the limit as x approaches 4 on the left, and you need the limit as x approaches 4 on the right of h of x. Okay, so let's do the left side. The left side, when I plug in 4, this is the left. And when I plug in 4, I get 4 squared, which is 16, divided by 2, which is 8. 8 minus 5 is 3, so I end up getting f of 3. And f of 3 is equal to 2. On the right side, if I plug in 4, I get negative 8 times 4, which is negative 32, plus 34, which is going to be 2. If I went too fast for you on that, please rewatch that again. So I found out that the left and the right hand limits are equal, If the left and right hand limits are equal, that means the limit is the same value. So this blue part is 2. And I had to show all that work. H of 4, on the right side, H of 4 is equal to this part, and we already plugged that in. When x was equal to 4, we had a 2. So this statement states that H is continuous at x equals 4. Okay? Now I'm trying to show that the function is differentiable so I can keep going. Now that I know the function is continuous, it could still have a sharp corner or a cusp or anything of that nature, so now I need to see if the left-hand, right-hand derivatives are the same. So to do that, I'm going to do kind of the same thing. I need this equation to be true. I need the left-hand limit to be the same, and I need the right-hand limit to be the same. And how do I get the left and right-hand limit? Well, I just take the derivative here of each part of the left and of the right. So of the left part, I'm going to get f prime of 1/2 x squared minus 5 times the derivative of the inside because of a chain rule. So 1/2 x squared, it's going to be an x. And that should be equal to the derivative of the right side, which is just -8. So now let's go to plug in 4. And again, I should still have a limit here in front. Okay, so now when I plug in 4 here, I get 4 squared, which is 16. 16 divided by 2 is 8. 8 minus 5 is 3. So now I have f prime of 3 times 4. Now let's see what f prime of 3 is. F prime of 3 is -2. So I get -2 times 4, which is -8. Which is -8 equals -8. And this statement, because this statement is true, means that h is differentiable and x equals 4. This is the only way to do the problem. It's a horrible problem because it's just so long, but it's doable though. It's again, continuity first, differentiability second, all limits. And again, you can see his answers, or her answer, whoever person did this, I think it's a guy, their answer is quite long as well because that's how much work it takes. And finally, for f, for this first part, we're going to let k be defined as the antiderivative of f, and it's known that, okay. So let's see what we got here. Let's go ahead and evaluate infinity right away. We can see from the first part that if we plug in infinity, we get negative infinity on top. If we plug in infinity on the bottom, we get, so let's see what the limit as x approaches infinity is, of h of x. Okay, so h of x is here. When x gets really, really, really big, I need a big number. And when I plug in infinity in here, I get -8 times infinity, which is negative infinity. So I get negative infinity. Well, negative infinity over infinity is just infinity over infinity, basically, I think. So we have to say that the limit is indeterminate as negative infinity. So negative infinity over infinity. I'll write that in. So L'Hopital's rule can be applied. Rule to solve limit. Okay, so as, let's see, negative infinity over negative infinity. Okay. L'Hopital's rule would say that we have to then take the derivative of the top and the bottom. So we'll need the limit as x approaches infinity of k prime of x over h prime of x. Now, this is a little bit complicated. We did h prime in the last problem. H prime is -8, so that part was not so bad. K prime, though. K prime, it says here, and this is a tricky sentence here that I didn't really go over at the beginning. It says k is the antiderivative of f. So basically, in case you need some unpacking there, k if you were to take the integral of f, that would be k, which means k prime is equal to f. So what I'm saying here is that we would get a limit still, as x approaches infinity, of f on the top over -8. Now f of infinity comes into play here. So if I'm trying to find where f goes to infinity, so we're trying to answer this. As x gets large, I'll type this out for you so you can read it. When you are trying to find the limit as x approaches infinity of f, what you're also stating is as x gets large, as x gets really, really large, as x gets large, what happens to the y value on f? So that's what you're trying to answer here. And they sneak in this sentence at the beginning, which is so sneaky. And they say that f has a horizontal asymptote of y equals -3. Well, horizontal asymptote is what happens to a function when x gets really, really large. So our answer here for this top part is -3. And there's our answer. And that's all for this video, guys. I'll make one more for the last part.